Good evening, Algebra 2. Today we're going to be talking about factoring, quadratic trinomials, and related polynomials. So we are going to be doing more factoring, which is, we've already kind of had a little bit of experience in factoring. So we're going to definitely still follow the three rules that I taught you guys before, and the three different types of factoring, doing them in the proper order. So remember, the first type of factoring was trying to find a GCF. The second time was using a special pattern, and if neither of those two worked, or you think you can factor further, then you go to guess and check. So, for example 1, it says factor the following polynomials. Let's take a look at letter A rather. Be x squared plus 10x plus 16. So, see if we can find a GCF. Our coefficient here is 1, so quite honestly, if that happens, you're not going to have a number you can pull out, but always check your variables. So here you have x squared, x, and then nothing. So that isn't going to work either, so no GCF. Moving to special patterns, can we square root the first thing? Yes. Can we square root the last thing? Yes. Square root of 16 is 4. So if I were to write this as a product of special patterns, I'd have x and x, and then I'd have 4 and 4, and then both of my signs would be pluses because everything's positive. Now this is where I said always, always, always FOIL it back out just to double check. So let's do that here. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And then 4 times 4 is 16. So then when I combine these two guys here, I get x squared plus 8x plus 16. Is that really what I want? I want a 10. So this is actually not going to work for us, and therefore we will not actually be able to use a special pattern. We thought we might be able to because we had that square root thing here and the square root thing here, but it didn't work out, which is why I say always, always check, because it might fool you like that. So since we can't use special patterns, then let's go to guess and check. So that's still set up the same way with two binomials. For this case, it's going to be x and x. So factors of 16 then are 1 and 16, 2 and 8, and 4 and 4. Now we just tried 4 and 4, and those didn't work. And then I always say to steer clear of 1 in something. It'll happen, but not that often. So let's actually try 2 and 8 and see if 2 and 8 work. So 2 here, 8 here. We need pluses on both of them, and let's FOIL. So x squared, and then plus 8x, and then plus 2x, and then plus 16. If I combine my x stuff, I have x squared plus 10x plus 16. Bingo! We've got to where we wanted to be. So let's go ahead and box this up. Well, I suppose actually I should look in here. Typically when you do guess and check, you're not going to be able to go any further, but you should always check. So x plus 8, nope, can't factor that any further. X plus 2, nope, can't factor that any further either. So we are done with this one. Let's take a look at letter B here. It's x squared minus 7x plus 12. So looking at our GCF, there's no coefficient here, so no numbers can come out. There's no x here, so no letters can come out, so we can skip that. Special patterns, we square root x squared, yes. Can we square root 12? No, so no special patterns. Let's jump then to guess and check, and that will look like this, with x's out front. Now 12, we need factors of 12 that add to 7. So listing our factors of 12, we have 1 and 12. We have 2 and 6. We have 3 and 4. And that's all. But I think I found something here. 3 and 4 do add to 7. So let's use those. Now they need to multiply to be positive 12, which means if you have a positive here, that's going to give you the same signs in your binomial. Okay. So I need either both positive or both negative. Now since this is a negative 7x, that means that I'm going to need both negatives here. So let's FOIL and double check. X times x is x squared. X times a negative 4 is a negative 4x. Negative 3 times x is a negative 3x. And negative 3 times a negative 4 is a positive 12. And we combine, so we get x squared, and then here we can boom change. So we have minus 7x plus 12. Did work out. That's what we started with. So these are our answers. And again, I can't take x minus 4 any further, and I can't take x minus 3 any further. So we are done with this one. All right, so let's take a look at the next examples here. Still example 1, we have parts C and D, so we're still factoring here. So let me write down our order that we do them in. First is GCF, 2 is special products, and 3 is guess and check. Okie dokie, GCF, no coefficient here, no x here, so no way. Special patterns, can I square root x squared? Sure. Can I square root 15? Nope. So all we're left with is guess and check. So let's set up our binomials. So we get x and x. Now we need factors of 15 that have a difference of 2. So listing out our factors of 15, we have 1 and 15, and 3 and 5, and that's really it. But 3 and 5 do have a difference, and when I say difference, that means we can subtract 1 from the other to get to 2. So 3 and 5 are the guys we need. So here's 3, here's 5. Now if I need a positive 2, that would mean my bigger number has to be positive down here if the bigger, or if our middle term is positive. So I need a plus here and a minus here, I believe, but we should always check. So let's do that. X times x is x squared. X times 5 is 5x. Negative 3 times x is a negative 3x. And negative 3 times 5 is a negative 15. When we combine, we get x squared. Plus 5x minus 3x is a plus 2x minus 15. So we're there. Can I factor any further? X minus 3? Nope. X plus 5? Nope. So that's our final answer here. Okay, let's check down here. GCF, I don't have a first coefficient, so no numbers are coming out. I don't have an x on the back end, so no letters are coming out here. Let's move to special patterns. Square root x squared, nope. Square root 24, or sorry, yes, this one works. But the square root of 24 does not work. So skip special patterns, go to guess and check, and we got to set up our binomials. We have x here, x here. Now we need factors of 24 that have a difference of 5. So let's take a look here. So we have 1 and 24. We have 2 and 12. We have 3 and 8. We have 4 and 6. That's actually it. So looking at these have a difference of 5. Well, these have a difference of 23. These have a difference of 10. Oh, these might work. Difference of 5 right here. So let's do 3 and then 8. Now, here I need a negative 5, which means my bigger thing down here has to be negative, or so we should think. So that should be negative, that should be positive. We need alternating signs because of this negative in the back. So let's FOIL out and let's see here. So x times x is x squared. X times a negative 8 is a negative 8x. Positive 3 times x is a plus 3x. And a positive 3 minus 8 is a negative 24. And then when we combine these middle two guys here, we get x squared. Negative 8x plus 3x is a negative 5x, and then minus 24. That's what we started with. Can we factor further? X plus 3, no. X minus 8, no. So we are done here. It is a rare case to be able to factor further, but it does happen. So you should always check. All right, so we have a couple more examples because, like I said, the more you do, the better you'll be. So I hope you join me for the next video.